Good day, everyone!
Hello, I am Teacher Justin.
And I am Teacher Kim.
And I am Teacher Maki.
And today, we are going to discuss the concept of cardinality of infinite, finite, countable, and uncountable sets. Good morning, class.
Good morning, ma'am.
Please all rise for a prayer. Mr. Pilago, can you lead the prayer?
Yes, ma'am.
In the name of the Father, and the Son, and the Holy Spirit. Amen. Before taking your seats, please arrange your chairs properly and pick up pieces of paper and cellophane if there is under on it. So, let's check our attendance. Okay. Wow, complete attendance today. Before we go on to our new discussion, I want you to know my rules first to have a harmonious and organized flow of discussion. Rule number 1. Respect. Respect me as your teacher, respect your classmates, and respect everyone's opinion. And then rule number 2, always follow rule number 1. Did I make myself clear, class?
Yes, ma'am.
Okay, class. What was our lesson last meeting? Yes, go ahead, Mr. Michael.
Our lesson last meeting was all about equinumerosity.
Great! Now, who can tell me what is equinumerosity? Yes, Miss Tampol.
Equinumerosity is when two sets or classes A and B are equinumerous if there exists a one-to-one correspondence between them. That is, if there exists a function from A to B such that for every element y of B, there is exactly one element x of A with f of x is equals to y.
Excellent, Miss Tampol. Good job, class. I am very much delighted to hear and know that you've understood and learned from my discussion last meeting. So, any questions and clarifications regarding with equinumerosity?
None, ma'am.
Okay, class. Are you familiar with the game 4 pigs and 1 word?
Yes, ma'am.
That's what we are going to do now. So here's the instructions. I will show you 4 pictures and then you are going to guess what that picture implies. You are only given 10 seconds to answer each set of pictures. Are you ready?
Yes, ma'am.
Let's start. So here's our first picture.
Infinity.
Okay. Then, next one.
Sets, ma'am, sets.
Next.
That?
And
And then number 4.
E! Elements!
And then last is...
Ma'am, that's count, ma'am.
Very good. Thank you so much, class, for your participation. You all did a great job. Before we proceed to our discussion, let's have an activity first. In this activity, you are going to count the characters in the given pictures. You can raise your hand if you want to share your answer on the following questions. So now, you are going to identify whether you can count the character in the picture or not. State "wemsu" if you can count it, and otherwise, state "esu" if you can't count it. So here's our first question. Yes, Mr. Michael.
Wemsu, ma'am.
Great. Then, second is... Yes, Mr. Pilago.
Eso, ma'am.
Very good. And the next? Yes, Mr. Viera.
Wemsu, ma'am.
Very good. The next one is... Yes, go ahead, Miss Adlawan.
Eso, ma'am.
Very good. And then last picture is... Go ahead, Miss Dangot.
Eso, ma'am.
Great. Since we are done to our activity, let us try to reflect these following questions. First, what did you observe in our activity? Yes, Miss Aurora.
We observed that each picture contains sets of animal, people, and things.
Then what did you do in our activity? Yes, Mr. Mandado.
We identify if it is countable or not, ma'am.
And how did you find the answer in the given activity? Yes, Miss Sabanal.
We identify the answer based on the number of elements in each set, ma'am.
Then last, what new insight can you share about the activity? Okay, yes, Miss Solarte.
I think we're going to tackle the cardinality of countable, uncountable, finite, and infinite sets, ma'am.
Yes, exactly. That will be our topic for today. For this lesson, these are the following objectives that we need to meet at the end of our discussion. Anyone who can read? Okay, yes, Miss Aguilar.
So, our objectives are: first, determine the cardinality of a set. Next, distinguish whether a set is finite or infinite and countable or uncountable. And then last, discuss the concept about the cardinality of finite, infinite, countable, and uncountable sets.
Okay, from the given activity you've just encountered, you're heading to a concepts of what is cardinality of uncountable, infinite, finite, and uncountable sets. So, you are already familiar with the concept of this in your previous lesson. First, let's start with what is cardinality. For example, in your family, you have your mother, father, sister, and brother. So, you are a family of five. It means that the cardinality of sets in your family is five. In short, the cardinality of a set is defined as the number of elements in a mathematical set. It can be finite or infinite. For example, the cardinality of set A is 1, 2, 3, 4, 5, and 6 is equal to 6 because set A has 6 elements. The cardinality of a set is also known as the size of the set. It is denoted by the modulus sign on both sides of a set named cardinality. Okay, next, let us talk about countable sets. To be precise, a set A is called countable if one of the following conditions is satisfied. First, A is a finite set. Example, set A is a set of 1, 2, 3, 4, and 5. So, what do you think is the cardinality of a set A?
5, Mom.
Okay, very good. Now, do you consider this as a countable set?
Yes, ma'am.
Alright, very good. Now, first second is if there can be one-to-one correspondence from set A to set N. Example, N of A is equal to N of N. It is called countable if you can put its member into one-to-one correspondence with the natural numbers 1, 2, 3, and so on. Example, a basket with infinitely many apples should be a countable infinity because you can label the apples 1, 2, 3, and etc. This point is used to determine whether an infinite set is countable. If a set is countable and infinite, then it is called a countably infinite set. Some examples such as sets are n, z, and q or rational numbers. So, the cardinality of a finite countable set is the number of elements in the set. On the other hand, if it is an infinite countable set, then its cardinality is equal to the cardinality of the set of natural numbers. Though, they're infinite because it is possible to list them rather. In other words, we can have one-to-one correspondence or bijection from each of these sets to the set of natural numbers n, and hence they are countable. Next is the cardinality of uncountable sets. In your own words, what is uncountable sets? Yes, Mr. Tonggol.
Uncountable sets are those sets that are not countable, Mom.
That's correct. As simple as that. A set A is said to be uncountable or uncountably infinite if they are not countable. The set of real numbers is an example of uncountable sets as we cannot list its elements and hence there can't be a bijection from R to N. The cardinality of uncountable infinite sets is either n of 1 or greater than this. Did you get it, class?
Yes, ma'am.
Okay, great. Now, let's move on to the cardinality of finite sets or finite sets. I know you're very familiar with this topic, are you?
Yes, ma'am.
So, the cardinality of finite set is nothing but the number of elements in it. For example, the set A is equal to the set of 2, 4, 6, 8. It has 4 elements and its cardinality is 4. Thus, the cardinality of a finite set is a natural number always. The cardinality of a set A is denoted by the cardinality of A, the n of A, card of A, or the number of A. But most common representations are the cardinality of A and the n of A. For example, if the set of A is equal to A, B, C, D, and E, then n of A or the cardinality of A is what?
5.
Yes, very good. That's 5. Next is, if set P is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, then what do you think is our n of P or the cardinality of P?
7, ma'am.
Okay, very good. 7. Amazing students. Then, let us now proceed to infinite sets. As we have already discussed earlier in the first section, the cardinality of a finite set is just the number of elements in it. But the cardinality of a countable infinite set, by its definition that have mentioned earlier, is n of n. And we use the letter from the Hebrew language, which is the Aleph Nal, which is denoted by n sub 0. It is used to represent the smallest infinite number. To denote n sub n, example, if set A is a countable infinite set, then its cardinality is n of A is equal to n of n is equal to n sub 0 or the null. An uncountable set always has a cardinality that is greater than the null or the n sub 0, and they have different representations. For example, the cardinality of uncountable sets. The set of real numbers or R, because if you were to ask what's the next real number after 1, so you could not actually say 2 because when we say real numbers, no matter what, you'll always have at least one number that is not included in the set. This set does not have one-to-one correspondence with the set of natural numbers. To summarize, the cardinality of any countable infinite set is n sub 0 or null. And the cardinality of an uncountable set is greater than the null or n sub 0. Okay. Any questions, clarifications?
None, ma'am.
Okay, none. Are you sure?
Yes, ma'am.
Very good. Now, let us proceed to the properties of cardinality of sets. Now that we know the meaning of the cardinality of a set, let us go through some of its important properties which help in understanding the concept in a much more better way. If A and B are two disjoint sets, then A union B is equal to n of A plus n of B. For any two sets A and B, n of A union B is equal to n of A plus n of B minus n of A intersection B. This is popularly known as the inclusion-exclusion principle. For any three sets A, B, and C, we have n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C and minus n of C intersection A plus n of A intersection B intersection C. The relation of sets having the same cardinality is an equivalence relation. A set A is countable if it is either finite or there is a bijection from A to n. A set is an uncountable if it is not countable, of course. The sets n to z and q are countable. The set R is uncountable. R is also known as real numbers. Any subset of a countable set is countable. Next is any superset of an uncountable set is uncountable. And lastly, if A and B are countable, then their Cartesian product A times B is also countable. So now I have here some examples. Tell me whether the given cardinality is countable infinite or uncountable infinite. And after that, you were to explain why did you say so. If you want to answer, you can raise your right hand, and if no one will participate, I will call some students in the class to answer my question. Is it clear?
Yes, ma'am.
Okay. Let's say group of islands. Yes, Miss Cabanyas.
It is countable infinite, ma'am, because it has one-to-one correspondence.
Okay, very good. What if I say all elements of real numbers? Go ahead, Mr. Kudo.
It is an uncountable infinite, ma'am, as we cannot list all its elements, and hence there can't be a bijection from R to N.
Great, Mr. Kudo. Last, all rocks in the world. I want Miss Viola to answer.
It is an uncountable infinite, ma'am. We can count it because no one knows in particular how many rocks in the world all in all.
You have a point, Miss Viola. Very good. Now, since you've already identified the difference between the finite, infinite, countable, and uncountable set, it is easy for you to answer the problem later.
I know you've learned a lot from this discussion. So, anyone who can summarize the lesson? Again, what is cardinality sets?
It is a number of elements in a given set.
Okay, great. Next, who can differentiate countable infinite and uncountable infinite? Yes, Mr. Tunggol.
A countable infinite set is one where you cannot count the next number, while uncountable infinite is you can't even begin to go to the next number.
Yes, you're right. How about finite sets and infinite sets? Yes, Miss Ebol.
Well, as far as I have learned, the cardinality of finite set is just the number of elements in it, while an infinite set, on the other hand, has an infinite number of elements, and an infinite set may be countable or uncountable.
Good job, class. You've really listened while I'm discussing. This lesson is very easy. You just need to remember these important things before we proceed on to our next activity. The cardinality of a set is the number of elements in the set. The cardinality of any countable infinite set is a leaf null. The cardinality of an uncountable set is a greater than leaf null. Before we proceed to our next activity, I will group you first into three. So, count off. Start with you, Miss Obejero.
1, 2, 3. The last number is 3.
You're going to make a concept map regarding from what you have learned from our discussion. It should highlight the concept of cardinality of countable sets, finite and infinite sets, and uncountable sets. You will only be given 15 minutes to make it with your group. After that, pick one representative to present your work in front of the class. Each group will be graded accordingly to the criteria that follows. So, content 30%, creativity 20%, teamwork 10%, and timeliness 10%, and last is the presentation, which is 30% and a total of 100%. Okay, go to your group now. Class, time is up. It's time to present your outputs. Okay, group 1, start your presentation in front of the class. Okay, give hands to group 1 for their amazing presentation. Next is group 2. Thank you for your outstanding presentation, group 2. Let's give them a hand. Now, let us proceed to our last presenter, which is the group 3. You may now start. Okay, thank you so much, group 3, for our amazing presentations. Do you want to know your scores?
Yes.
Okay, for the group 1, you got 95 points out of 100. Not bad. For group 2, you got 98 points. And lastly, for the group 3, you got 96 points out of 100. Okay, congratulations everyone. You all did a great job. Job well done, class. I know you can do it. So, at this point, let's have our short quiz. Okay, for the direction, read each question carefully and choose the letter that corresponds to the correct answer. Number 1. This refers to the numbers of elements in a set. A. Cardinality. B. Countable. C. Finite. D. Infinite. Okay, number 2. Given the set A, blue, red, yellow, red, and green, what is the cardinality? A. 3. B. 4. C. 5. D. 6. Number 3. Which of the following statements is true about infinite sets? A. All infinite sets have the same cardinality. B. Every infinite sets are countable. C. There are different sizes of infinity, and some infinite are larger than others. Or letter D, infinite sets cannot be compared in terms of size. Number 4. Considering the following sets, which one is an example of an uncountable infinite sets? A. The set of all real numbers. B. The set of natural numbers. C. The set of rational numbers. Or letter D. The set of all prime numbers. Number 5. Which of the following sets is an example of finite set? A. The set of all even numbers. B. The set of all prime numbers. C. The set of integers. Or letter D. The set of clothes, shoes, and jacket. For your assignment class, advanced research on the topic arithmetic and ordering of cardinal numbers. Write your answers in a one whole sheet of paper.